Yes, today, being the 6th January 2026, we kick off with the OCA lesson classes. Today we're in physics. So today we're going to talk about calculations in physics. We're going to do calculations in physics. The first one we're going to talk about today goes to equations for accelerated motion. Let's first of all list, like as I listed, we have equations, 4 major equations for accelerated motion. When you are talking about equations for accelerated motion, we talk of motion that is going straight, linear motion. Are you getting what I'm saying? So when we're talking about accelerated motion equation, we're talking about linear what? Motion. Just motion on the level what? Ground. Are you with me?
Yes.
So now these are the equations. The first equation says S equals half bracket U plus V close bracket T, or T bracket U plus V all in brackets, then all over 2. Either this or this can go in the first equation. Good. We use this equation to calculate distance covered linearly on a straight ground when initial velocity is given, final velocity, and the time when they are what? Given. When initial velocity, final velocity, and time are given, we use this first formula to calculate distance covered by an object on a straight line. Are you get what I'm saying? Very good. Now, in the second equation, we use it to calculate final velocity. The equation says V equals U plus AT. Note that S is distance, U is initial velocity, V is final velocity, T is what? Time. Good. Now here, this is the second equation of accelerated motion, which I've just stated as V equals U plus AT. Are we there? We know that V is final velocity, U is initial velocity, then A is acceleration. Are you getting me? That is linear what? Acceleration, because we have acceleration due to what? Gravity. We're coming to that. Then T is time. So we use this formula to calculate final velocity of an object that is moving on a straight ground when initial velocity, acceleration, and the time are what? Given. That is when we use this formula to calculate the value of final velocity of an object that is moving linearly on a straight what? Ground. Are you getting me?
Yes.
Remember, whenever we're talking about linear motion, you know, in motion under gravity, which we use G, acceleration due to gravity, to replace small a. So, on the level ground, acceleration due to gravity is 0. Are you getting what I'm saying?
Yes.
That's why I'm not going to see them here. Then, when we now talk of any motion going up or coming down, that is where you have issues with acceleration due to gravity. Anywhere you see small a will be now replaced with small g. Are we getting what I'm saying?
Yes.
Now, in the third equation for accelerated motion, we use it to calculate final velocity when u is given, the acceleration is given, and the distance is given. Are you getting me?
Yes.
So the formula says v squared equals u squared plus 2as. So we use this particular formula to calculate final velocity when initial velocity, acceleration, and the distance are what? Given. Following? Good. Now, and the last one we have here, that is equation 4. We use it to calculate distance on a straight ground when initial velocity is given, time and acceleration are all given. We use it to calculate distance on a straight ground. Remember, the distance here we have, okay, in the formula we have S equals UT plus half AT squared. Now, we notice that we have three distances here. In case sometimes they will give us calculation to calculate distance, you have S here, you have S here, you have S here. There are things you check.